Very good afternoon, everybody. The presentation about network security is that. Now what?
Exactly. So, quick introduction. I'm Joost Hage, Field PM for Zscaler. Don't worry, we won't go too much into vendor marketing stuff. We do try to actually talk about the topic, but realize that the things that we're saying specifically apply to the things that we do.
My name is Put-Carstens. I'm a CTO at Watchmen. Watchmen is a consultancy company, fast-growing company in the Benelux region. We provide consultancy around zero trust, and I think that my history is I've also worked at Blue Coat and also at Zscaler. So this is why Watchmen was basically founded on these kind of technologies, and we are very happy that Joost from Zscaler is willing to give us a good presentation.
You'll regret it afterwards.
yeah. So let's get started.
Without further ado. So, first of all, why this topic in the first place? And I think it's realistic to say I've been in this business for about 30 years. Yes, indeed, I am that old. Essentially speaking, if we look at how we approached things 30 years ago, sure, things got more complex, maybe more sophisticated, but essentially speaking, we're sort of getting into the same type of problems. We have stuff that we want to or need to expose to other people, and then we use firewalls, IDS, IPS, web application firewalls to then protect those resources, and that's essentially what we've been doing for the last 30 years.
Yeah, and you see that every device, every platform, every security solution even has vulnerabilities. So even though that you can have new solutions, you always will run into new vulnerabilities in new systems, basically making it possible for attackers to find a way in.
Absolutely, and those could be cameras, those could actually be the same types of devices that you are implementing to keep those attackers out of your network. And I think the problem is a fundamental one. On the one hand, you have networking, which is created to make it as easy as possible to connect things together, right? You have clients, destinations, they need to talk to each other. And you want to do this low latency, you want to have redundancy. So essentially speaking, you've built an infrastructure that if it finds a problem, it will route around it. And at the same time, on the other end, you have security where you want to prevent this from happening, or at least prevent this from happening to people who should not have access to that. But from a networking perspective, that security component suddenly becomes a quote-unquote problem. So, there will be ways to then route around it or attack it directly. In general, I think that's what we've seen in the last decade, is that the actual devices, again, that protect you are also targets themselves. And once you have a entry point in a network, even if you have some local segmentation, you still pretty much are able to expand and expand your foothold, get actually access to those things that you want to protect specifically.
Yeah, and everybody knows the term lateral movement. So when they are in, they can laterally move, and it is also very easy in most environments to get out with the data and do the data exfiltration, because mostly the entry is pretty closed, but the exit or the way to the internet is pretty open.
And again, the networks themselves are built to give all those users, all those devices access to the other stuff that they need to do. Again, that's why you have them in the first place. So again, I feel strongly that if you rely on your network to start protecting your environment, you essentially sort of get the wrong assumptions. And if you look at it in slightly more detail, one of the issues that occurs is that you have a client who wants to connect into an application. That application needs to be able to respond, right? You send out a packet, needs to respond to that packet, and you could put in place something like a firewall, an IDS, or some other security controls in the line, in the middle. But essentially speaking, they will still need to allow that packet through until they have a broader context of what's going on.
So really network-to-network communication, IP-to-IP communication, which makes it very difficult to have a secure environment that is less vulnerable. So
yeah, very much so. So if we then look at Zero Trust first of all is not just a point solution, it is a philosophy, it's an approach, it's typically will impact architecture, infrastructure, but the very first starting point of Zero Trust is that you remove any specific inherent trust of the network itself and you move into identity, right? So you make sure that before you're able to do anything anywhere, you first need to know who the user is, what application, what device they're using, if their health, so you try to build up that trust first. And then once that's the case, you no longer need to rely on the network. So essentially you can sort of say, I expect my network to be breached, but I don't necessarily need to care because I can isolate them. If you're on the network, you don't automatically get access into anything anymore, simply because that's not the way that you provide that access. At the same time, even if you determine that someone or some device is allowed to contact another application, you still need to monitor that. You still need to make sure that whatever is being exchanged, whether it's data or applications or whatever it might be, that you're in control, that you see what's going on, so you can build up sort of those protective measures. And then finally, when you do get sort of into a position where all those things are in place, it becomes time to sort of minimize the access that you would have would be allowed to go to in the first place. So you get into a least privilege model where you really try to tie down the access that those individuals' devices have.
Since Zero Trust is a philosophy, a framework, you could say, there are a lot of different ways or frameworks, so to say, that you can use to get started with Zero Trust within an organization. So it doesn't really matter which framework you choose. Basically all those elements that you see here are part of all the frameworks. They have different priorities. Some focus a little bit more on identity, some focus a little bit more on data protection, but they are basically all referencing the same principles.
That is a great point. It's not a either or. Obviously, I mean, if identity is key to your access, then you need to make sure that identity is well defined and well managed. But if you then have this new parameter, if you start enforcing identity, but a person on the network is still able to do whatever they want, you still really haven't solved anything. So it is not a or, it really is a sort of collaboration of different components. So, from our perspective, what does that look like? How do you make sure that you can actually start enforcing this, that you can sort of get rid of that open network design? Well, first of all, we have something we call a Zero Trust Exchange. So the very first thing that happens is that a device, a user, it could be anything, initiates a connection not to the network, well, I mean, they'll have to be on the network, but specifically to that exchange. And when they do, we can start looking, who are you? We can look at identity, we can look at what type of device are you using? Are we sure that we can trust this device? Once we've established that, yes, okay, we at least have sort of the minimum requirements, we can start looking at, okay, what is it that you're actually trying to do? Which application do you try to access? Is it something on the internet? Is it something internal? And would you be allowed to do that in the first place? Let's say that you actually do have the, you're allowed to go to a database or to Google, I don't care. When that happens, again, we have to look at the actual content. So if you have something like a TLS connection for HTTP, you have to inspect that, right? So you have to make sure that you look at content, look at the broader context, and you need to continuously do that. And then finally, once we've established that, yes, indeed, the risk is okay, we accept that, we allow this connection to occur, to flow, we can then actually start to establish it by, if you go to the internet, take a specific connection into whatever it is. But if you go to internal applications, we actually have another trick to remove exposure. So instead of connecting into your network, we actually have a component, we call them an app connector, that itself needs to create its own trust relationship that we need to trust, make sure that it's not compromised or otherwise problematic, but it initiates an outbound session into our exchange, which means that from a connection perspective, we never need to do anything towards that component. So we don't need to expose it on the internet, we don't need to expose it on the internal network. For all means and purposes, it doesn't exist, except, see, my enthusiasm. I'll just stop there. Except for the fact that it initiates that connection. We can then use it to piggyback onto that, to use it as a forwarding channel to the actual application itself. And of course, final component here is that when this happens, we build up a history of this as well. So if we see a user suddenly doing something that we deem risky, obviously we'll block that connection. We can then also use that information for additional connections. So we see a user trying to download malware. That's not a great sign. Next time that they go to the internal SAP server, maybe we'll just block them, or maybe we just want to make sure that they are who they are, so we'll enforce multi-factor authentication. And again, this is something that you can do dynamically.
Yeah, and as we explained this is what we call mostly zero trust network access, but also protecting the users for internet access. You see on the bottom also some other type of devices, like applications connecting to other applications, and OIT of IT devices or OT devices connecting to infrastructure. So it's not limited to a user, it can also be a device, a process, an application to other applications. So zero trust is not only about giving a user access to an application. But this makes the example a little bit more easy than going through all the elements of zero trust, because it's basically a philosophy that you have to spread out over your whole environment and not only on the application access level.
No, great point. Yeah. So obviously, if you have a device, things like authentication will be different because you typically don't have the interaction. Maybe you can do jaw tokens or OAuth or things like that, but it's typically harder to do on those types of devices. Also, if you do posture, so if you want to check whether a device is healthy, if you don't have anything running on that device, it's going to be really hard to do. But yes, there is a complete different session just on how to then mitigate that risk. So, practically speaking, what does this mean? What is the first gain that you get? If you look at a typical traditional secured environment, you'll see and firewalls to protect specific access to the internet. Of course, remember, if you have something like an SD-WAN will use the internet as well. They will need to respond to the other peers. So essentially, they are going to be visible on the network too. And very importantly, once you're on the network, users, same thing. But once you're on the network, everything essentially becomes a target, right? I mean, if it's a camera, if it's a server, everything is in and of itself is accessible. And even if you start segmenting up these networks, typically what you'll find is if you find one vulnerable component, it will have some peering relationship, will have the ability to reach something else on the inside network. And if you just enumerate, in the end, you will be able to get into this network. So what's our sort of approach then? Well, like I mentioned, we introduced this Zero Trust Exchange. That's where all connections get initiated to. So first of all, if we look at it from a networking perspective, we have components that will automatically build up tunnels and build up their own trust relationship. And as they do so, because they don't have any inbound connections, again, you remove their exposure to the internet. And the same is true for your users. Once you get a user, typically you'll install an agent just because life is easier that way. And as you do so, you start protecting them, and you start allowing them to communicate with internal resources through that zero trust exchange. And because you enforce the use of that exchange, it also means that the internal exposure goes away. Again, obviously, you have to make sure from a networking perspective that you start isolating, you move users out of the network. You might want to do some micro-segmentation on the devices themselves. But this approach allows you to do it without actually having to go through a complete what needs to talk to what type of process.
Yeah, and if you look to this different approach, you see a lot of new policies that need to be enforced and built. One thing that we do a lot at Watchmen is automating the configuration of the security policies within the Zero Trust Exchange, making sure that application teams that have a new application that they want to be allowing access to for internal employees, they make sure that they can provide this within the DevOps teams themselves. So basically security is already part of the development cycle, which makes it much more integrated for the future.
Yep.
And also if you look to here the diagram looks a little bit like that you only have it if you want to connect to a data center or to a cloud. But the strength of implementing Zero Trust application access is that it works also for your internal users connecting to your internal data center. Not every company wants to be using cloud applications, especially nowadays, so they probably have still resources within the corporate data center that they also need to be accessing. And these are also secured about through the same way, but the difference here is that the Zero Trust Exchange is not only on the internet as a public service, but it's also extended towards the data center. So even if the internet is down, you still can enforce all your Zero Trust policies the same way as if the cloud was still there.
Yep.
From a business continuity strategy, very important to have that feature.
Yeah, no, absolutely true. Yeah, the one of the key points is that this is completely network independent. We don't care if these are fiber optics, if it's Wi-Fi, if it's the Starbucks at the end of the street, regardless where your traffic is coming from, because the flow is always going to be managed this way, you always get the security as well. All right, then of course the next sort of interesting question is, okay, so first of all, what makes a good Zero Trust solution, and second, why should we trust them in the first place? First, on the first thing, what makes a good Zero Trust solution? Well, first of all, from our point of view, it needs to be global. It needs to be available wherever you are. If your user is in Amsterdam today or Utrecht, they need to just open up their laptop and connect to a closed node and be able to do the work that they want to do. And if they move to, Washington, then the same should apply. They should open up their machine, they should have a local node available, the policy should automatically follow them, and they should again be able to work, do the things that they want to do, regardless of where they are. Automatically that means that this needs to be a multi-tenant solution, because this won't work in a situation where you have to pre-provision a device or a node or a POP, right? There has to be an automatic way. Which also means that the same security principles must be available everywhere, right? Your node, again, in Amsterdam, must be able to do the same security, the same sandboxing, SSL inspection, whatnot, as in any other part of the world. And then finally, and I do think this is important, it needs to be optimized for performance. In my opinion, user experience is a security feature, If you create something that users don't like, they will be very willing and very, in many cases, very able to circumvent that solution and essentially negate all the work you've done. So you have to make sure that it works the way that users like to actually work with it. And then on the second bit, the actual, okay, that's fine, but why should we trust you? Well, I think first of all, we have a economic incentive to make this work, right? It's we make money by securing you. So if we don't do a bad job, that would be bad. Also, I think in a similar fashion, security is in a way your responsibility, but it's probably not going to be your core expertise. So that means that you should be able to provide the right policies, to be able to set all the things that you want to implement, but you have to be able to do it without actually being an expert. You should have tools around that to allow you to do your job that way. And finally, of course, don't just trust us, right? Audit, make sure that you look at the actual traffic flows. Because of the way that things are being reported, you have full visibility. Use that to occasionally, watch the Watchmen specifically.
Yeah, and I think that the trust is always a little bit strange, because even if you have like a zero trust environment, as soon as you start making connections to other systems to verify the trust, like your IDP, your identity provider, like Entra ID or whatever you are using, you're already building a trust, and you have to start somewhere getting your information. So it's always like, in a broader sense, a stack of security solutions that must be able to follow those principles of zero trust.
Yeah. Well, in cloud, I'm sure most people are aware of the sort of shared responsibility model, where on the one end, the cloud provider makes sure that the cloud itself is safe, but if you run applications in it, you're still responsible for those types of things. In a similar way, we are a security solution. You still need to make sure that your policies are actually, enforcing the things that you want to enforce. The data that you're protecting, that you're sort of aware what that looks like to prevent it from ever leaving.
And the final thing is that your policy is your policy. It's not that there's a definition of a policy that is used by, in this case, Zscaler, that enforces something to you. You can decide what you like. If you set everything open, it still will be as open as it was before.
Yeah. Although, fortunately,
a little bit more secure, because there's no inbound connections anymore, but still.
And we still remove that attack surface, yes. All right, so zero trust as a popular term exists for a little while now. The newest buzzword there is AI. Let's take a look at what AI is doing in our field sort of generally. And I think for us specifically, we see a few specific trends. We see on the one hand, on a negative view, we see that it allows specific adversaries to take a different look at either the components that they can attack. They can look at different ways to attack things, and they can more efficiently automate attacks. At the same time, for us, it means that we can use the same sort of the telemetry that we see by virtue of all the traffic passing through our cloud to actually start discovering new attack patterns and look at different ways of anomalies. So it actually is a tool in our benefit as well in that regard. And the same is actually true for you. So not just from a security perspective, but also on a performance point of view. Again, the traffic flows through us, so we can actually show you telemetry and then provide tooling to actually say, okay, I see that this group of users has issues going to, Microsoft. Why is that? Is that a problem with a patch that just got installed? Is it maybe because the path that they take to there it has some performance problems? If yes, can we route around that? Again, it gives you a different view of the world that you can leverage that way as well. Obviously, in DLP, if you know how language works, it might be easier to pick up specific things like credit cards. But at the same time, I've seen some interesting examples of organizations that use AI tools and accidentally suddenly start exposing internal information. So again, it's good to take a different view of that type of traffic as well. But for us specifically, it's a good tool to actually get you to a better understanding of what is talking to what, and then allow you to create policies, right? If you know that you've got these servers over there and you've got clients from with a specific type, maybe you have a specific Active Directory group, you see them communicate, you can actually say, okay, apparently this is what those types of users are supposed to be doing, let's create a policy around that. And by giving you those insights, including some confidence level where we'll say, I'm about 90% sure that this actually correlates, it allows you to set up those policies, which are otherwise really hard to do. All right. So, very quickly, we kind of mentioned it before, Zero Trust is not a point solution. It's not something that you just buy and now we're done. You have to sort of integrate that with the other things. It's fine to focus on a specific topic first, so you can go for your networking or maybe identity or target specific types of devices, but in the end, if you want to properly deploy this, it is not a or, it really is, or you need to have a way to combine all those elements to make sure that you have this general policy, this general security footprint. And the advantage is once you start doing that, you're not just gaining security improvements, it will actually allow you to do better collaboration within your internal teams as well. I mentioned the potential conflict between networking and security. I don't know what that looks like for you, but I occasionally see organizations where the networking team is very reluctant to speak with the security team, or if there's also a cloud or application development team, they tend to have very different goals. By approaching it this way, there are ways to provide specific flexibility for all those teams, so that the networking team can focus on the things that they want to do, low latency connectivity. Security team can do the things that they want to do, enforce sort of this least privileges, make sure data doesn't leave, even if you have multiple data paths, even if there's a redundant network environment. And cloud teams can set up these things without having to go through a full change management process. They might get the flexibility to first turn off specific inspections, specific policies, until they're ready, start applying in that, and then they can move into production where all of this is getting enforced.
Yeah, and at the top you see a few of the statements there on, for example, in the middle, the ease collaboration between DevOps, security, and so on. That's what I meant by integrating those platforms, making it sure that you use automation. At the end you see the connectivity as code, like what we build for customers, making sure that they get to the right connectivity, not based on a policy with users clicking through the portal, but really automating that process. And also all the integration that you see, really important to understand all those facets of the interconnecting platforms and making sure that those are secured and safe as well.
So, a few takeaways. Again, I'll keep repeating this until the end of me. Zero Trust is broader than just a solution. It really is a philosophy. It will involve transformation of your infrastructure. It will involve it will require you to think broader on what is it that my network should look like, what is it that I want to actually provide to my end users. It shifts trust. You move away from you're on my network, therefore you're safe, you're trusted, into if I know who you are and I know your risk model, maybe you're not necessarily trusted, but I do trust the fact that if you do something weird, that we can dynamically adapt access to you. And then finally, it applies to everything. It's users, it's applications, it's cameras, it's OT, IoT. All of that is part of the zero trust model.
Yeah, this reaches our end of the presentation. Of course, we are here to answer some of the questions that you might have after the presentation. You can visit our booth next to the entrance, but also, just have a talk outside of us with everybody who has a shirt with Watchmen or Zscaler. We can explain what we have been talking about and if there's any more questions. And I'd like to thank you very much for your attention.
Right.